Okay, so this is going to be part 2 of your quadratic word problems notes. You need to look for this page in your notebook. We've already finished examples 1 and 2 on part 1, so you are supposed to do example 3. And before we finish the part 1 video, I told you if you're going to be able to pick out A, B, and C, one thing that I recommend is you moving around the original equation that was given to you into a true standard form with your exponents in order. Now you have A, B, and C, the way you are used to looking at it. You can still pick A, B, and C out of the original as long as you remember A is in front of t squared, B is in front of the t, and C is the constant with no variable at all. So, I've already drawn a graph for us. You say, thinking to yourself, Miss Lusher, how did you know to make it start here rather than starting down at 0, 0? Here's how I knew. A man at the top and near the edge of a 10-meter tall building throws a ball vertically upward at a speed of 5.2 meters per second. He is already 10 meters in the air when he throws the ball. So the ball is 10 meters above the ground. And then it gives you the equation. Now, before I start calculating a lot of stuff, I'm going to look at what I need. I am asked about the maximum height. When does it reach the maximum height? When is the ball back on the ground? And then how high is the ball after 1.2 seconds? So I need to know the vertex. I need to know when is the ball going to be on the ground. That's an x-intercept. That's going to require me to use the quadratic formula. So I'm going to start by maximum height, finding that vertex. That's what I'm asked for first. So I need this vertex. How do I find vertex? Well, if I don't know that, I go back to my foldable in my notebook that tells me about standard vertex and intercept form. You use x equals negative b over 2a. So you look at your equation and you make sure you pick out the right b. B is 5.2, a is negative 4.9. So I plug in 5.2 and a negative 4.9. I type that in my calculator and I get 0.53. That's my x. So that tells me that my maximum height occurs at 0.53 seconds. But what this question asks me is, what is the maximum height of the ball? So in order to find maximum height, now I need to actually plug that into my equation. I can plug into either the original or this one that I used. H of 0.53. I'm going to plug into the original just to show you that that's okay. 0.53 minus 4.9, 0.53 squared. Now when I type this in my calculator, I get 11.38 meters. So what does that mean? Well, it means at 0.53 seconds, the ball is at 11.38 meters. Remember, it started at 10, so it's not a whole lot higher. It didn't go up a lot higher than where the man was originally standing. So the question, what is the maximum height the ball will reach? The maximum height is 11.38 meters. B asks you, when does the ball reach its maximum height? At what time? When means time. Well, that's at 0.53 seconds. Now, if they were asking me this on a test or a quiz or my end of course test, I would probably make this a little fancier and I would write the sentence. The ball will reach its maximum height at 0.53 seconds. Or the ball will reach a maximum height of 11.38 meters after 0.53 seconds. But for now, in my notes, I just need to make sure I understand where I get these numbers. C asks you, when does the ball reach the ground? The ground is 0 height. Here's 0 height. What axis is that? That's your x-axis. You need to know your x-intercept here. So I'm going to use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I typed these two in my calculator. And when I typed these two in my calculator, I found out x equals negative 0.99 seconds and 2.05 seconds. In this context of this problem, what does not make sense? A negative time cannot happen. Therefore, you don't use this one. So when is it back on the ground? At 2.05 seconds. Not 2 seconds, 2.05 seconds. It's when the ball returns to the ground. Now part D asks you, how high is the ball at 1.2 seconds after being released? Your function tells you the height of a ball in respect to time. This is a time. That's t. Plug it in for t in the original. H of 1.2 equals 10 plus 5.2. Plug in 1.2. Minus 4.9. Plug in 1.2 squared. When you type this in, you find out at 1.2 seconds, the ball is at a height of 9.184 meters. It is important that you use your labels and you name your units. Meters. That's a lot bigger than 9.184 inches. Completely different measurement. What I would like for you to do now is I would like for you to try examples 4 and 5 on your own and compare them with those sitting in your group. And then come back to this video and I will explain the answers to examples 4 and 5. Here is my completed answer to example 4. Your work should look the same as mine. So let's look at what example 4 is about, and I'm going to explain to you how I got these answers. Example 4 says the senior class is putting on a talent show to raise money for their senior trip. In the past, the profit for the talent show could be modeled by this function, where X represents the ticket price in dollars. So what this equation is doing is they're saying if we change the ticket price, which is where I put on my x-axis, what is that going to do to my profit? Okay, so I want you to look at the graph that I did. I didn't start at 0 because I'm not going to charge people $0 to come into my talent show. My y-intercept is negative 4,000. That would mean I intersect way down here. Okay, so if I intersect way down there, of course I know I'm going to not cross at 0. Now, I didn't know what these numbers were when I first sketched my graph. All I knew was the y-intercept was way down here to the negative, and it wasn't going to be at 0. What is the maximum profit? I used x equals negative b over 2a. That's how I got 18.75. Well, how do I find the profit itself? I plug it in. I plugged in my maximum ticket price, and then I got out $1,625. That is my maximum profit. What is a reasonable domain and range for the function? I did range first when I wrote this because I know the lowest profit I'm going to get is 0. The maximum profit that I could get is right here. That's that 1,625. So 0 less than or equal to y less than or equal to 1,625. In order to do domain, I had to calculate my x-intercepts, my zeros, the roots, the solutions. And the method I chose to use was the quadratic formula. Because honestly, I did not want to try to factor or complete the square with these numbers. So when I did the quadratic formula, I found two answers. That one ticket price could be $8.67 and another ticket price could be $28.83. So if you look at this, as the ticket price increases, your profit is increasing. But then once you reach a maximum ticket price of $18.75, your profit starts to decrease again, and then you make $0 at $28.83. Think about what would you be willing to pay to get into a talent show. The more it costs to get in, so the more the ticket price goes up, the less people are going to be willing to actually go to that talent show. So you need to make sure that you have this work on your notes as well. Here's example 5. Example 5 is about a golf ball. It's shot from the ground. So right there, I know that my y-intercept is 0. That's how I knew to start my graph here. The golf ball is on the ground, so it's at 0 height before you shoot it, which is 0 time. So of course, I needed to look to see what I was asked. I was asked, assuming the ball lands on the ground level, what is the reasonable domain and a range? If I need to know range, I need to know the minimum, the lowest point I'm going to be at, which in this case is 0, and the maximum height. So how do I do maximum? I find that vertex. Negative b over 2a. Here's my x. When I know x and I know a function, I know the function because it's given to me here in the problem. I plug it in. That's how I find my vertex. Knowing my vertex allows me to write the range. The height of my ball will be somewhere between 0 and 351.5625 meters. So now I need to know domain. I need to know what is the lowest x and the highest x. These are called my x-intercepts. They're called the solutions, the roots, the zeros. If I need to solve, I have to either do quadratic formula, factoring, completing the square. I chose quadratic formula. And when I worked this out, I got 2 answers, 0 and 9.375. That means at 0 seconds it's on the ground because I haven't hit the ball yet. At 9.375, the ball has returned back to the ground, which gave me a domain of 0 less than or equal to x less than or equal to 9.375.